Hello, insert greeting here. We are going to be analyzing functions, dealing with some old stuff, some new stuff, but all good stuff. So let's take a look starting with domain. If you recall, the domain is just all possible x values. Similarly, the range is all possible y values. And we've done these before. Remember, we can write these in interval notation or set builder notation. Now our x and y intercepts, that's where the lines cross the x and y axis. The x-intercept will find where y equals 0 or f of x equals 0, then you solve for x. And the y-intercept will find where x equals 0. We plug that in and solve for y, or our f of x, which y and f of x are kind of the same thing. Alright, going to some new stuff. Looking at continuity. Now continuity, let me give this some space here. Continuity refers to a graph that does not have any breaks or gaps in it. So this, for example, would be a continuous graph because there aren't any breaks, there aren't any gaps. I can draw this whole graph here without picking up my pencil. Let's take a look at an example of an discontinuous graph. A discontinuous graph might have something that goes like this. Notice we're going along our graph here, and then we have this big gap, all of this, and then we have to continue back down here. Now that is discontinuous. We have a discontinuity right here at the x equals 0 line. Decreasing and increasing refers to a function's slope at a specific part in the graph. So it could be a positive slope, in that case it would be increasing. It could be a negative slope, in that case it would be decreasing. To simplify it further, a decreasing slope is going downwards and an increasing slope is going upwards. So I'm just going to draw a graph here, and hopefully you'll kind of get the hang of it, decreasing and increasing. So here we're decreasing, still decreasing. Say I shift up, now we're increasing. Now we're going upward. If I shift back down, we're decreasing. Now even if I start to level out, I'm still decreasing. I'm still going downwards, just slower, but it's still decreasing and still decreasing, still decreasing. Okay, now we're increasing. Increasing, increasing. As long as we're going up, we're increasing. As long as we're going down, we're decreasing. It doesn't matter how drastic or how steep the slope is, just as long as it's going up or down. The end behavior of a graph just refers to what's happening at the very left of a graph and what's happening at the very right of the graph. So in this function here, for example, as we move left on the graph, this function is getting bigger and bigger and bigger, and it's going higher and higher all the way up to 1,000, 2,000, all the way up to positive infinity. So the left end behavior is positive infinity. On the right side of the graph, here we're going the opposite way. We're going downward all the way to negative infinity. So the end behavior, we're just looking at the behavior of the graph at each end, the left and the right. In this case here, as our graph moves to the left, it's getting closer and closer and closer to the x-axis. And remember, this x-axis value, y value, is 0. So as we move to the left on this graph, we're getting closer and closer to 0. On the right, even though our graph looks very different on this side, we are still getting very, very closer and closer to 0. So the end behavior on the right is also 0. You're going to be using all these different ideas to analyze and graph functions. So make sure you're very familiar with these different concepts.